Welcome to my session today, Introduction to Analysis Services Models in On-Prem and Cloud. I want to introduce myself. My name is Madhuri Mantri Pragada. I go by Madhuri. I'm a business intelligence developer. I have almost 9 years of experience in business intelligence development tools, ETL, and working in the data warehouse. Currently working on migrating on-prem data warehouse to cloud. So participating in some of these data engineering conversations within our company, having plans to migrate all the on-prem business intelligence reporting to cloud. I also did my master's in computer science. So with a major of database systems, more inclined towards and more enthusiastic towards upcoming trends in data science, data engineering, and business intelligence overall. It's a little bit of introduction about me. So coming to today's presentation about analysis services models on-prem and cloud. I thought of doing this presentation in two different ways. One, I thought I should start presenting about analysis services models itself, but then I thought I should take a step back and talk about what's BI and how these analysis services models fit into this big picture of business intelligence architecture. So there is, without taking much time here, I'm gonna just start with this my abstract slide. Not gonna go over reading this. We'll just jump right into the agenda. So here I'm going to start with high level BI architecture and development. Along with that, we'll also go through what are semantic models. We'll go through what is a relational and dimensional modeling and what are the basic dimensional modeling concepts. We'll also go into multidimensional tabular models, some of these tabular model features, best practices, development and deployment tools, and a little bit of demo for how a basic SSAS model is built, and also how we use DAX Studio to monitor some metrics to use in the performance optimization. I know this is a very extensive agenda for an introduction to SQL Server analysis presentation, but I will try to keep it to the high level as possible. As I go through the presentation, if there are any questions, please feel free to post those questions. I'm planning on taking them at the end, or however the presentation goes. I might check with my moderator to take the questions in between. So with that, I'm going to start with the first slide here. What is BI? So it's a business intelligence is a buzzword. I'm pretty sure most of the people who have joined today probably must have heard working on it or dealt with it. Since my presentation is about introduction to analysis services, I thought I'm going to take this time to talk about BI. So in this pyramid, data is at the lowest level, actionable insights is at the highest level of the apex of the pyramid. So data is the raw and unprocessed facts that are usually in the form of numbers and text. Data can be quantitative and qualitative. It can be measured or it can be observed. It can exist in databases to spreadsheets. It can technically reside in anywhere from an Excel sheet to a database. Information is prepared data that has been processed and aggregated, organized. It gives more context to the data, and mostly information is delivered in the form of visualizations, reports, and dashboards. And insights are generated by analyzing the information. Like when we look at the report or a dashboard, we'll be able to draw some conclusions out of the report, which are an actionable insight. For example, a sales professional trying to look at how much sales they have done in the last couple of days and how much sales they need to do in the next couple of days to reach their goal for a week. It's an actionable insight for that salesperson. So business intelligence leverages the enterprise's data to provide actionable insights to the management. Across the world, all organizations are generating a lot of data, online transaction systems, weblogs. The goal is to turn all the data into the meaningful information for management. It could be used for improving the customer satisfaction, improving profits, deliver values, or deliver costs. The goal is really to have better insight of what customers actually need, how to sell their product. So BI plays a crucial role in transforming this data into actionable insights. So let's take a case study of a multinational telecommunication company. They have operations in various countries. They collect a lot of data. We know if we sign up for a service with a telecom provider, they have call records, network usage, billing, customer demographic information. It's all a lot of data they host in-house. Probably it might be in a different systems, but that data is going to improve their business if they analyze it appropriately. So BI enables the organization for this telecommunication company in this case study to identify the patterns, correlations, trends, and help them streamline their revenue streams or marketing strategies, whatever the goal is. So BI enhances the operational efficiency. There are different tools for BI. BI is a very abstract word at this point. So I just wanted to underline the fact that how a crucial role BI plays in transforming raw data into actionable insights. So this telecommunication company can improve its operational efficiency by analyzing the data which they already have in different systems. So we'll go through how it actually is being done in the upcoming slides. So in the high level BI development, there are 3 layers of development. You must be wondering why I'm not going through architecture before going through the development. Me being a developer, I think that gives more perspective in what fits into this high-level BI development. So database layer, semantic layer, and presentation layer are 3 layers in the BI development. So in the database layer, it can start from Excel sheet to a SharePoint location or a SQL data warehouse or an on-prem, any relational database, cloud database, anything can come under database layer. Semantic layer, it covers analysis services. It can be Azure analysis services or SQL Server. In SQL Server, we have tabular and multidimensional. In presentation, anything that includes visualization. Those charts and graphs, it can be part of SQL Server reporting services, Power BI, Tableau, ClickView, any visualization tool. So there are 3 layers of high-level BI development. And
Madhuri, before you proceed, one quick thing. We are seeing the screen shared is the presenter's view versus the actual slide presented. Do you want to switch?
oh, sure. Okay. I can.
I mean, if it's difficult, I initially I didn't see it was hidden on my screen. I just realized.
Oh, so you can see the notes on the slides. That was the
Yes,
issue.
yeah, that was instead of the actual slideshow.
Okay, yeah, that's fine. I can.
Okay.
Can you see it now?
Yep, now it looks good.
Sounds good. Okay. So going to the high level BI architecture, we can ingest the data from different source systems, which is on-premise, cloud databases, mobile applications. We should be able to ingest the data from multiple sources uh, using the data ingestion, and we prepare and massage the data using different tools, load it into the data warehouse, and which can be used as a source for BI semantic models. And the endpoint here is the reporting. Reporting can use the BI semantic models as a source. On a side note, a data warehouse can be on a different server, and BI semantic models can be on a different server. So they doesn't need to be physically present on the same server. It can be on its own, and have usually BI semantic models are analysis services models. That just sets right into our topic of discussion today. Any analysis services model is a database deployed on the analysis services instance of a SQL server. We'll discuss more in detail in the upcoming slides. How these semantic models, what are these semantic models, what are the different types, benefits. Going through semantic models, it focuses on a single subject area, widely shared. It describes concepts, relationships, and standards. It enforces fine-grained data permissions, and also it helps improve the query performance. There are two types of models, relational and dimensional model. Relational modeling is entity relationship modeling, mostly used normalized tables because it involves so much of OLTP, online transactional processing. It is best to have normalized data to remove redundancy out of data, because it helps with easy inserts, updates. So it has one to many, many to many, all these type of relationships. Just because there are many tables involved here, the querying would be complex, because we need to join many tables to come to a aggregation, any to do any further analysis. So coming to the dimensional modeling, it is designed for easy queries. It produces fewer tables than entity relationship model. And also it can create the redundancy because of the data warehousing, the concept itself. We sometimes denormalize the data to be able to use it for our further analysis, whether either in the modeling or in the reporting. There are different dimensional modeling concepts, dimensions, facts, relationships. So we are going to talk about it a little bit here. So dimensions describe business entities, where and what of an entity, like products, people, places, time, all comes under dimensions. Dimensions usually support filtering and grouping, and facts have foreign key to the dimension table, meaning that we will have the dimension key value in the fact, which acts as a foreign key. Measurements, anything that need to be summarized or aggregated, those values we use it under measurements. So facts are mostly used for supporting the summarization of the data. There are different types of schemas. Among them, star, snowflake, and galaxy are the popular schemas. So we'll talk about star schema here. Dimensions are on the one side of the relationship, and facts are on the many side of the relationship. Multiple star schemas makes the galaxy schema. Here's in the snowflake schema, we see not all dimensions are related to fact. directly. Here, date, dimension, store, product, customer, they relate to sales fact table directly, but a month, week, quarter, city, they are not directly related. They are indirectly connected or related to the fact table. So this makes a snowflake schema. Um, so let's get into the SQL Server analysis services. So just to trace back our steps from high-level BI architecture to this slide here, SQL Server analysis services fall under semantic modeling, a layer of the overall BI architecture. So it helps summarization, aggregation. Um, it's an analytical processing of data from different data sources. The benefit of SQL Server analysis services is to extract the data for analyzing to help decision making. It helps with the complex aggregations, helps with the slice and dicing of the data. There are two types of SQL Server analysis services. It's multidimensional and tabular. I know it's tabular is a keyword for a very long time, and then Microsoft is releasing more updates only to tabular since I think 2017, 2018. We are seeing more updates in tabular, but not in multidimensional. But some organizations still have multidimensional models. I think it is a good time for us to evaluate what are the benefits of having tabular model over multidimensional. So here, multidimensionals are more scalable. They support complex query construction. I feel with my multidimensional models, we need to prepare the data ahead of time for us to do some row level transformations. We cannot do it on the model, but we can do aggregations, all the calculations. It can be done in the multidimensional model, but just that we need to prepare the data to a level where we can do these aggregations. So multidimensional expressions is a query language which is used in calculations for multidimensional models. The security is defined at the cell level. So going to tabular models here, they are more performant. They have entity relation model type of look and feel. It's easier to develop because many people are acquainted with that ER modeling aspect of it. It supports many types of data sources, any IBM, DB2, Oracle, Cloud, any data sources, tabular model supports more than multidimensional. It all depends on memory because it's an in-memory database. We will talk more about it in the upcoming slides. In tabular models, the row level transformations can be done within the model. And the aggregated values are stored in the memory. So talking about aggregated values, for example, a company wants to do an year-over-year sales analysis for last 10 years. We do not have to store all the aggregations for all the 10 years data in the model. Instead, we can store the data at the lowest grain and then let the tabular model does its aggregation using its measures and calculations for all the 10 years of data. So the benefit is we don't have to store all that aggregations for these many years, whatever the use case you have. We don't have to store the aggregations. It will be performed based on the user query to a report. And also we use data analysis expressions. It's a query language different from MDX. It's used in tabular modeling. The security can be defined at the row level. It's not at the cell level. We'll talk more about row level security in the upcoming slides. The use cases for the tabular models is we can use the SQL Server analysis services, Azure analysis services, and Power BI as well, because Power BI also has tabular modeling it supports tabular models. It's just that the model is within the Power BI as a service and not on a different server. That's the key difference. Um, as I mentioned, it uses the same entity relationship modeling concept, so it's easier to understand, develop. Data is in highly compressed mode. There is an X velocity engine. Microsoft has this technology called VTPAC, which accommodates the high level of compression. Um, for example, if there is a database you have, and if you are creating a tabular model on top of it, it would compress the model 1/10 of the size of the actual database as an approximate. But whereas in the multidimensional, it compresses at 1/3 of the size of the model. So that I think that actually defines what is the key distinction between multidimensional and tabular. Highly compressed, more performant. It's in memory. So those are highlights of the tabular modeling. SSAS loads the data from semantic models into the memory RAM, since it's an in-memory model. So this is a tabular architecture. We have we can collect data from different sources here. Tabular supports all the different types of data sources, relational, on-prem, cloud. We have a storage engine. One type of storage engine defines a VTPAC. We have a data model, the DAX calculations, and Power BI report. So when a user submits a query through a report, it's sent to DAX calculations and it reaches out to the semantic model, and it will get the data from the in-memory storage. So this is a high-level tabular architecture. It's a column store engine. There are two type of engines DAX calculations have. It's formula engine and storage engine. VTPAC keeps the snapshot of the data in the memory. For storage engine, it can refresh from time to time. That is the periodic refresh here. So let's talk more about the row store versus column store database. We are talking about tabular models. We said it's an in-memory database. It's a column store, highly compressed database. So we'll talk about what is column store. In the row store database, it has increased I/O, many scans of unnecessary data on the database. If you see here, date, store, product, customer, price, these are all the different columns for each row. So in the row store, we store the data by rows, self-explanatory as the name suggests. In the columnar database, it's optimized for vertical data scanning, meaning each of these columns are stored separately. And it could be physically separated too. Date column is all compressed and stored separately from store column, and so on for product, customer, price. If there are multiple columns that need to be involved for a computation, there will be intermediate columns that will be created to store the intermediate results. So since VTPAC is column store, it would be easier for it to search through the compressed column and get the results back. The cardinality of the each column plays a pivotal role in the column store database. So in the column store compression, there are two types of encoding it can use. It can be a dictionary encoding or a run length encoding. In this picture example, uh, it's using run length encoding. There are like 400 rows which has blue color, but instead it's going to create a dictionary is saying, okay, blue color is starting from 1 and it has 400 row count. So instead of storing and compressing the data for this table, it's going to store the information this way. Repeated values will be more compressed, meaning it can compress better. That's the reason why the cardinality of a column values are more important in the columnar store compression, and also sort order may impact within the table for the compression to be better. There are two types of query modes: direct query and import mode. We will talk a little bit more detail here. Direct query mode, data remains in the source system. The flexibility, it's flexible and scalable. Um, but just that it's limited to a few DAX functions. We may not be able to use some time intelligence functions like quarter to date or month, year to date. Don't exactly know the syntax of it, but some of the functions are limited here, and calculator tables are not supported in the direct query mode. It's mostly suited for the real-time data processing. Its size of the data, if it is very large, maybe it's petabytes of data, then a direct query. But mostly used query mode is in import mode. Data is loaded from different sources. It's compressed and stored in memory and in a columnar format. It helps the faster query performance, and it's best suited for not too large data volumes. It can be refreshed more frequently. There is no baseline for how much the data volume should be. Because with Azure Analysis Services, it can store a model up to 400 gigabytes of compressed model. So there is no real baseline. It depends on what is the use case you have and what type of data you're dealing with, the factors that are going to influence the decision of whether you should use import data or direct query is like size of the data, the frequency of the data updates, or the complexity of the model and the performance requirements. Based on that, we can choose either or mostly used is import mode. So DAX is a data analysis expressions. It's a query language. It looks like a Excel um, formula. It's collection of functions, operators, constants, and it calculates and returns one or more values. It is to create new information from data which is already in the model. We can create measures. We call it as calculated measures. So for the query processing, when it reads the data source, transforms and compresses the column data, and it establishes the dictionary and index. And it establishes the relationships, computes the data, compresses the calculated columns, and returns the results. That's the high level query processing. So there are different features of tabular model. First of all, we should understand that it supports different types of data sources. There are different relationships we can use within that entity relationship model, one-to-one, one-to-many, and many-to-many. We'll talk more about many-to-many in the best practices section. Previously, we used to have performance issues. We still have performance issues based on the type of data we use when we use many-to-many. We use different calculations, calculated measures, calculated columns. Actually, there is another concept called calculated tables in the tabular modeling. We do not have to create a table or retrieve the table from a source database. We can actually create a table off of the already imported database tables and create measures and columns. Yeah, so there are many features around calculations there. And for processing, we can use partitioning technique. We can create partitions for if you have 20 years of data in the model, then you can partition it by the date or year of your data. So it will help improve the processing performance. There is row level security. Tabular model can, we can define row level security. We should be able to define filters within the roles. We can use DAX functions for dynamic security like username, user principal name, and apply filters at dimensions or fact level. For example, you want a user to be able to see the limiter customer data set within the model, then you can go ahead and create filters at the customer dimension. You can define a filter at that level saying if this user logs in, restrict the customers to this region. We can do that using the row level security feature. So let's go into the demo of the analysis services tabular model. So I have a AdventureWorks database. So I just try to create a simple model to go through. Please let me know if everyone can see my Visual Studio screen here.
Yes, we see that.
Okay. Okay. So this is a Visual Studio data tools used for business intelligence development. So you can import different you can import from different data sources. Currently, I have used a SQL Server data source, and I used I have imported few dimension tables and one fact table, and this is a calculated date table here. So there is a diagram view and table view. You can see the table view here, and this is the diagram view. And you can create relationship between fact and dimensions. Currently, there is a one-to-many relationship between fact internet sales to dim customers on customer key. There can be multiple customers exist in the sales table, but there can be only one customer in the dimensional customer table. So this is how you define the relationship between different tables. And you can use time intelligence functions to calculate year over year, month over month type of calculations. You can also create calculated columns. Here, margin is a calculated column, which I calculated using sales amount and total product cost. So it's calculated for every row here. And you can also define calculated measures like distinct counts, order count, total units, and you can also do total sales using sum, average, first, last, max. We can do many aggregations here, and we can also create KPIs. We can also format the columns, like what type of format you want. Do you want it to be a decimal or a integer whole number? We can format. We can format the type of the data. We went through data sources. We talked about relationships. We talked about tables, and let's take a look at roles. So we can define RLS security, as I mentioned. We can define it at the table level. We can define filters. So here I'm saying sales analyst US. I want the sales analyst, whoever logs in to look at their report, should be only restricted to the US country region. So you can define a DAX filter here, and you can define the members. You can define the email groups or individual user emails here. So, I mean, this is a very simplistic representation of how the RLS security works in analysis services model. So once the model is ready, you should be able to deploy this. We should be able to build and deploy to a SQL Server tabular instance. Once it is deployed, we can deploy it and process it at the same time. Otherwise, you can choose to deploy it first, deploy the metadata first as a .bim file, and then process it using on the SQL Server tabular instance. So let's take a look at. So after I deployed the model to the tabular instance on the SQL Server, I have the dim customer, dim date, dim geography. These are all different tables we have. We should be able to evaluate. This is a DAX format of select in SQL. So if you do F5, you will be able to evaluate the table and see the results. And you can do complex evaluations, set the filter criteria, and see what the table, how the table is being filtered. Once going back to the presentation, we did go through the high level analysis services tabular model design and development. And we also saw how we can use SQL Server Management Studio to do the query execution. Moving on to the best practices, we can avoid. It's better to avoid many to many. It's not easy because of the use case you have. It's not always easy to avoid it, but we can avoid it by creating intermediate bridge tables. Many to many relationships causes performance issues. They can lead to incorrect results because there might be that uncertainty in understanding when the query is being evaluated, which relationship to use, that type of that may lead to the incorrect results. The best practice is to create an intermediate table and create the relationship to the bridge table, and use it for your filtering purpose, which will help better performance and accuracy when querying it. Best practice number 2, use DAX measures instead of calculated columns. The problem is columns are stored in memory. It will slow down the performance of the model. So practice is to use DAX measures. If you cannot come to a calculation in one measure for readability sake, you can create multiple intermediate DAX measures, which can be used in your final measure calculation. So measures don't take up extra space or cause performance issues during processing. They are more flexible than calculated columns. Um, it's best practice to hide unused columns and tables, obviously to keep the model to organized and keep it clean, easier to find whatever you're looking for. It's a best practice. Also, just to be aware that SSA scans all the columns and tables in the model, so it may slow down the performance if it is looking into unused columns and tables. The other best practices is to use low cardinality columns, meaning if there are any repeated values within a column, then it will have low cardinality, because the distinct values of that column will be limited. It will accommodate with faster query performance. Star schema is a buzzword again. People say use star schema, your model will work effectively. It's not possible all the time, but at least try to get into the star schema model, um, model type of schema. At least that will help with the query execution. And the suggested naming standards for calculated columns and calculated measures. You can prefix the table name for some columns within the DAX queries, and you don't have to prefix the table name for calculated measures. So it will be easier when you're reading through the model.bim file. Then you would be able to figure out, oh, this is a calculated column, this is a measure, so it would be easier to read. So let's look at Vertipack Analyzer in DAX Studio, and also look at the sample report I have created with a couple of visuals. So this is a DAX Studio. It's a free open source tool, very cool tool. It will help you evaluate some stats about the data you have in the model. As you see here, I can use DAX query in the DAX Studio, obviously, and I can run the DAX queries on this DAX Studio to validate the tables, or also for this demo, I'm only using simple evaluate expressions. We can also use complex expressions with the filter criteria, all that, to validate and analyze whether your query is performing as you expected. And you can also use Vertipack Analyzer. It's in the advanced view metrics option. You should be able to see how many rows you have, what is the cardinality of your column, what is the dictionary size, what type of encoding it uses. And even for the relationships, you would be able to look and understand what is the size of my customer key column within the fact internet sales table. And we can also, I think, take a look at it and understand, okay, my cardinality for this column in this table is high. Where am I using it? Is it required? Um, i- how can we clean up the model better so that we can achieve higher performance through our analysis services model? The type of analysis can be done through Vertipack Analyzer, which is embedded with the DAX Studio. So feel free to use that. And we can also create a Power BI report using the SQL Server Analysis Services tabular model. So I have created a Power BI report using the model which we have seen before. This is deployed to a SQL server instead of tabular instance on the SQL server. So I've used that model as a source to create this Power BI report. We can create many cool visuals. It will give you an high level overview of how it's been used. Here in this visual, how much sales road bikes have done than mountain bikes. We'll be able to see and answer, okay, road bikes are making more sales. And we can also compare it with the cost of that item which was sold. This is an internet sales data which I use from AdventureWorks, a database Microsoft provided. It's a free database, anyone can download and use it. So I'm not going in detail about how a Power BI report is created and all that. Just wanted to make sure we all see that we'll be able to see the modeling when I'm connected to a SQL Server tabular instance from Power BI, and then I'm able to see the model within my Power BI. I won't be able to make changes on it, but I would be able to add calculations, calculated measures, and I can also treat as DAX syntax to create more relationships, and so on. So going back to my presentation, let's get into more detail about licensing. SQL Server Analysis Services is single instance of analysis services, run either tabular or multidimensional. Memory, processor, disk space depends on the user requirements. It's not so easy to scale up and scale down when compared to Azure Analysis Services, because SQL Server involves hardware. But Azure Analysis Services, it's easy to scale up and scale down because it's all in Azure environment. It's a click of a button. There are different tiers, developer, basic, and standard. Plans and costs vary depending on the tier. You can choose whichever tier you want to use for your organization based on the processing power, memory size you need for the models you have across your organization. So Power BI licensing, there are different Power BI licensing, Power BI Pro, Power BI Premium, different tiers within the premium capacity, P1 to P5. There is a 1-year commitment for anyone who is in the premium capacity. The reason why I'm talking about Power BI licensing is because users can create models, analysis services, tabular models within the Power BI because it supports that as well. In this new era of self-service business intelligence development, modeling is not just restricted to the developers, it's also scaled across different business users, power users, if you say, people who can query and create smaller models and make sense of the data. They can create a simple model within Power BI and create a report for their organization.
Hey Madhuri, because you had asked to inform you, we are at the 10-minute mark. We have 10 more minutes to go.
Sounds good. Thank you. So I think I have only a couple of more slides here. Just want to give a high level on-prem and Azure Analysis Services model differences. There is no multidimensional option on the Azure Analysis Services. But if you want to migrate your multidimensional model to the cloud, you can do it through an Azure VM. But you should be able to migrate your on-prem tabular models using an XMLA endpoint, but that need to be enabled in your Power BI capacity admin settings. Then you should be able to migrate your on-prem models to Azure. So there are different development utilities, SQL Server data tools, Tabular Editor. You can use DAX Studio, SQL Server Management Studio, and Power BI Desktop. Different utilities based on your preference of development. You can use any of these tools. For deployment, you can use SQL Server data tools or deployment wizard or Tabular Editor or Azure DevOps or Power BI pipelines to promote your report models to higher environments. These are the references. So I can take any questions. I know I said this is introduction, but I know that I went in detail about the query processing and high-level solution architecture for BI, but please feel free to ask any questions.